What actually happens when an LLM generates an answer? This process is called inference. Inference means using a trained AI model to produce an answer. And here is the surprising part. Even with a powerful GPU, the model usually generates the answer one token at a time. First, your prompt is divided into small text pieces called tokens. A token can be a whole word, part of a word, or even punctuation. These tokens are converted into numbers called embeddings, which the model can process. The model has already been trained, so its learned weights do not change during the inference. Only the text sequence keep growing. The first stage of inference is called a prefill. During prefill, the transformer process your entire prompt. A transformer is the prediction system inside the LLM. Because all the prompt tokens are already available, the GPU can process many of them in parallel. But the model does not generate the entire answer during the prefill. It looks at the final position and predicts what tokens should come next. For every possible token, the model produces a score called a logit. Softmax converts the scores into probabilities and a decoding method chooses one token. For suppose, imagine a prompt ends with the sky looks. The model may choose blue, but it cannot correctly predict what comes after blue until blue has actually been selected here. The model could instead have chosen dark, clear, or strange. Each choices create a different continuation. So the decoding stage of inference follows a loop. Predict one token, choose the token, add it to the sequence, run the model again. This method is called autoregressive generation because every new token depends on the token that comes before it. A KV cache here makes this faster by storing useful calculations from the earlier tokens. The model does not need to completely recalculate the entire conversation every time. GPU can also perform large calculations in parallel and process many users together. One answer still has a token by token dependency. This explains the rhythm you see when an LLM streams its answer. The first pause often includes the prefill. Then each new pulse of text comes from another decoding step. Inference is not one giant calculation that creates the full answer instantly. It is a sequence of predictions connected by choices. Techniques such as speculative decoding can guess several future tokens and verify them together. This can make inference faster, but it does not completely remove the dependency between the tokens. A powerful GPU can accelerate this type of calculations, but it cannot perfectly calculate the next future before the current future has been chosen. This is how LLM inference works.